Now, we operate the layout setting software. Double-click to open it. We enter the home screen. Here, we can create new programs, open saved programs, as well as customize some settings and utilities. Generally, we mainly create and view saved programs. Let's click New. Firstly, choose the size of the ceramic block. There are many types of ceramic block. Size 12 hashtag and 14 hashtag are most popular, but size 14 hashtag also has several dimensions. Here are size and length under each ceramic block. For example, the Anamic and Soprinity have different length, one is 17.8 and the other is 18.6. Bases on different ceramic blocks and brands. We can set up a new one. Click Setting, select Stocks, select Rectangular Bar, enter the password admin, and click Validate. Input the parameters on the right, including its name, which can be customized. Then its size, it must be the same as the actual dimension of the ceramic block. Please pay attention here. We measure the size in this way. There are 3 sides, and the longest one is the length, L. The narrowest one is the height, H. The last side is the width, W. We can see the 3 parameters, L, H and W in the created ceramic blocks. We need to slightly increase the length L. Each ceramic block may have a little error. In order to prevent the burr from directly hitting the ceramic block, we need to lengthen the L value slightly during the setting up. For H and W value, we normally take the actual data. If the L is measured at 17, we can input 17.2 or 17.3 in the length, that is, to increase the length of 0.2 to 0.3. And for H and W, if H is measured at 10, then input 10. If W is measured at 13, then input 13. For material selection, choose glass ceramic. Just leave other parameters as they are. Click Validate, and then return to the home page. Now let's create another program. Click the star icon in the lower left corner to create a shortcut, so that we can directly click the shortcut later to enter the page of creating new program. Input any name here and click OK. Then a new shortcut appears on the home screen. Click here directly to create a new program. Then select a ceramic block and click Next at the lower right corner. The workflow follows through the steps of the menu. The first step is to import data. The second step is to select the sequence and draw the cavity. Normally, we don't need to draw the cavity. Currently, most scanners will generate data in 2 files, the STL file and the PTS file for cavity. The next step is orientation. Orientate the dental model to a suitable position for milling. The next step is to add a connecting pin, and then to calculate the milling path. First, click the plus icon to import a data, select the folder, and then import a crown. Here we import the STL data. Now we can see the crown. Right-click the mouse to rotate the crown. Press 2 buttons of the mouse simultaneously to drag the tooth. Scroll the wheel in the middle of the mouse to zoom in and out. Most of these icons on the right are used to view the crown from different angles. This is the block holder system, which demonstrates the block holder we are seeing now. The block holder is the metal base on which the ceramic block is fixed. We recommend to display it all the time, because when orientating the crown later, we need to use the small pin on the block holder as a reference. There are many icons for extra functions, but most of them are not necessary. I won't cover them here. We can change the ceramic block here. We just chose the 14 hashtag size. Since the crown model is smaller, it shows that the 12 hashtag size also fits it. So, we can replace it with the 12 hashtag size. Now we can see that the ceramic block becomes smaller. Using correct ceramic blocks can save material and avoid wastage. Any suitable and applicable ceramic block will be displayed while those inappropriate will be filtered out and hidden. If we place a larger restoration, select the data, and then click the cross icon to delete the smaller block. We click the plus icon again to import the data. Import a larger one, a veneer. The 12 hashtag ceramic block we used just now is no longer suitable. At this point, we can choose a larger 14 hashtag ceramic block. It fits well. Let's continue with this veneer. Here we just imported the data. Then we need to click Next for the second menu and select Sequence. Here we can select the sequence. Move the cursor to the restoration and right-click to select the appropriate sequence. Our sequence covers inlay, crown, and veneer. This is the veneer. Just select the veneer. Click Next to draw the cavity. There is finished cavity. We can see the cavity at its edge, and don't need to highlight it. Just click Next for orientation. Here is an important step. Double-click the veneer, and there will be 3 colored lines. Click the lines to rotate the veneer. There are several basic requirements for the orientation. Firstly, orientate the surface of adhesion to the pin. Adjust the surface of adhesion. Whether it is inlay, veneer, or crown, the surface should be face the pin. The labial or occlusal surface should face the opposite direction. Secondly, we should orientate the veneer till the zone highlighted in red disappears. As the burr is unable to mill the red zone, we need to orientate the veneer till it disappears. We can remove the red zone by adjusting the green line and the red line. The burr mills from outside in on both the right and left sides step by step. The burr is perpendicular to the pin. So, the red zone is inaccessible by the burr. So, we should adjust it till the red zone disappear, then the veneer can be milled. This orientation should work. Then click OK. Please pay attention on 2 points when orientating the restoration. The first one is that the surface of adhesion should face the pin and orientate the tooth to make the red zone disappeared. There is also a requirement for the veneer. Try to place it at 45-degree angle against the surface of the block holder. If the tooth is placed at 45 degrees, there will be many inaccessible areas on its edges, that is, the red zone. The burr can't access it, so we need to adjust the orientation. That's it. In this window, these plus and minus icons is corresponding to the red, green, and blue line. The restoration will be rotated at 1 degree interval when we click the plus icon. Can also be rotated at a larger interval, say, 5 degrees, 10 degrees or 45 degrees. A larger interval will make a larger angle of rotation. Just click Validate here. Then go to the next step to add the connecting pin. There are also some basic requirements when orientating the connecting pin. This angle cannot be adjusted because any adjustment will produce a small included angle. As a result, the burr may be unable to access there and be broken. So, this adjustment is prohibited, and please do not adjust the angle. Just adopt the default angle. However, we can manipulate the front and back arrows. Adjusting that region can make the milling process in a more balanced way. Try not to put the connecting pin in the too high position. If we put it too high, those areas will not be accessed. Since the burr comes in this direction vertically, these areas cannot be milled. In addition, after milling, more area is needed to be treated, so we should put the connecting pin in a lower place. That's it. Click here on the left to select the thickness of the connecting pin. We generally recommend a minimum of 2.5 to a maximum of 3.5. For this veneer, 3.0 is more suitable. Select the shape of the connecting pin, which is round by default. And there is an option of oval shape. However, the oval shape is not recommended because the connecting pin would be more fragile, and it is fine to use the round shape by default. We also can adjust the angle of the tapered connecting pin. Now it's a 10 degrees cone. If we set it to 0, the pin becomes a cylinder, not a cone. It is 10 degrees by default, but it can be adjusted between 7 degrees to 10 degrees. However, it is recommended not to change it. It is fine to keep the default setting. Then click the next for the tool path. Just click the calculate. This function is also used to calculate tool path, but they run in the background. Let's click the calculate first. Then we can see the tool path displayed here. The progress bar will run until it is completed. A few things to note. There are tool paths of error, empty, and edit. If there is an error tool path, return to the previous step to readjust the orientation, possibly because of few inaccessible areas in the red zone. If there is an error, then this tool path is invalid, so we must readjust and recalculate it. If there is an empty tool path or an edited tool path, it doesn't matter. It is valid after the calculation. After calculating the tool path, it shows a prompt because there are two empty tool paths. The prompt will also appear if there is an edited tool path. Just click OK and leave it as it is. Then you will hear a music, which indicates the successful calculation of tool path. The calculated tool path will be stored in a NC folder at D drive. So, make sure the computer is equipped with a D drive. Open the NC folder at D drive. Here is a toolpath file which was just calculated. Just transfer the NC file to EasyMill through the software, then can start milling. Next, let's process a crown. Click the new shortcut and select a 14 ceramic block. Click the plus icon to import STL data. The crown. Check whether there is anything wrong with the design. If not, open it directly. Import it. Click Next. Right-click the design. Select Crown. And click Next. It already has cavity here. Let's try to draw the cavity. First, delete the original one. Double-click the crown. Click Cut the margin. Select the cavity, and click with the mouse to delete the cavity. After all are deleted, click Validate. Then we try to manually draw the line. Click the cavity icon. Then, draw the line along its edge. You can draw it between the outer rim and the inner rim. Click the mouse to draw along the edge step by step. If we make mistake, press the backspace on the keyboard to let it return, and then continue to draw. When drawing, press and hold both buttons of the mouse to drag the model. Right-click the mouse button and press and hold it to rotate the crown. Try to click the turning point. Finally, double-click one of the points to connect the cavity, then it is finished. Then click Next. Here we need to reorientate the crown. Now we can see it still has many red zones. Double-click the crown to adjust it to an appropriate size. Because it doesn't need to be adjusted too much, we orientate it via the plus and minus icons on the left. If there are red zones on the right, rotate the red line to the left. If there are red zones on the left, click the plus icons and rotate the red line to the right. Please note that the surface of adhesion and the tissue surface should face the pin, but the occlusal surface and the incisal edge should be in the opposite direction. Don't misorientate it. The surface of adhesion shall face the pin. Also, its opening shall be placed horizontally. We need to adjust the blue line. Horizontal opening means that the opening of this crown is oval shape. We need to place it horizontally, and the two longer sides should be parallel with surface of the block holder. We can't put this opening vertically in this way, because the burr moves from the outside in step by step. If the opening is placed vertically, it is difficult for the burr to mill inside because of the smaller space. Place the opening horizontally. The wider space it has, the burr is easier to mill inside. So, when mill full crown, there are 2 points to note. The first is the position of the pin. The surface of adhesion should face the pin. In addition, if the opening is oval or rectangular shape, we should place it horizontally. Click Validate, and then Next. Besides, we don't need to adjust the angle of the connecting pin. Just orientate it back and forth. It is recommended to place it in the middle. If placed here, the connecting pin will affect the shape of the occlusal surface. Because it occupies these places which required further grinding after milling, so it is better to put the connecting pin in the middle. If it is placed further to the right, the connecting pin may affect the cavity and balance. Moreover, the contact point may be easily broken during milling. Generally, 3.0 is the suitable thickness for the connecting pin. For such a larger tooth, just keep other parameters. Click Next. And then Calculate. When it is completed, the crown data will be displayed. Let's make another inlay too. Click New, select the ceramic block, and import the inlay data. Click Next. Right-click to select the sequence of the inlay. Then click Next. If the inlay already has cavity, just skip the drawing, and click Next. Double-click the inlay, orientate its surface of adhesion to the pin, and then adjust the red line at this position. Find the correct location for connecting pin. The connecting pin will extend from the hole. After proper positioning, the connecting pin can be connected where we need it later. The direction is basically adjusted. The left side needs slight adjustment. The connecting pin can be connected here. Check if the position is aligned with the hole. If not, rotate the blue line. If it is in the groove, it will be difficult to be grinded after milling. Click Validate, and then click Next. If the position is off, return to the previous step and redo it. Any error can be undone. Then double-click the inlay, and it will prompt whether to delete the pin. Click Yes, and then rotate it a little bit. It's still not suitable. Return and rotate it again. It is better now. The connecting pin is basically well placed. Click Next. Click Batch Manager, and let it calculate the tool path in the background. When we continue to create another restoration, the current one will run in the background. After the calculation is finished, we can import the STR file to EasyMill for milling.